let's do something very interesting. Let's visualize, that is understand in a diagram, let's visualize factorization of a quadratic polynomial. And that method can be used to find the roots also. So we'll visualize both. But first, let's visualize factorization of a quadratic polynomial. For example, take x square plus 5x plus 6. Now when it's an equation, we'll make it equal to 0. Now, what is x square in a diagram? X square is nothing but you take a square with side x. Now, to get 5x, first let's take x. What is x? If you want to visualize here, x is a rectangle. So I take a rectangle here with length on top of this x square, where length is x, but take breadth as 1. So you get x square plus x. Now, if I take this 5 times like this, I'll get x square plus 5x. So x square plus 5x is the area of this rectangle. 6 is still outside. But as per our method of factorization, what we are supposed to do is that 6 into 1, you are supposed to write as product of two numbers. You can either write it as 6 into 1. So in a rectangle, it will look like this, where length is 6 and breadth is 1. Or you can take it as 3 into 2, where the length is 3 and breadth is 2. But while doing this, you should make sure that sum of this length and breadth is matching with the coefficient of x, or 5x in this case. Now, that is why this 3 and 2 will exactly match. So, now coming back to this area x square plus 5x, this 5x you can split as 3x and 2x. So, I'll bring this 3x down here. 2x is left on top. Now, this rectangle will get completed when, what is the remaining region here? That rectangle is with length 3 and breadth 2. So I can directly take this 3 by 2 rectangle and fill it here. So it's a complete rectangle now with length x plus 3 and breadth x plus 2. So area of this rectangle is nothing but, if I take length into breadth, x square plus 5x plus 6, which is our original expression. So x square plus 5x plus 6. Initially we had 3 separate diagrams, one square with area x square, rectangle with area 5x, another rectangle outside which I kept outside with area 6. But when you bring all of them together, we are still getting x square plus 5x plus 6, but we are factorizing it as length and breadth. Length is x plus 3 and breadth is x plus 2. So very interesting way to connect a method which otherwise can be very boring or monotonous when it comes to just factorizing the way we've been using numbers before. But when you visualize, I'm very sure it's very intuitive, interesting and easy. So we just visualized factorization of x square plus 5x plus 6. Now next, using the same thing, if I make it equal to 0, I'll get a quadratic equation. So solution for that is very easy to visualize here. That's what I'll do next. Now we can find the roots of the equation also. We already got x plus 3 into x plus 2 equal to 0, where visualizing x plus 3 is actually the length and x plus 2 is the breadth of this particular rectangle. So you can make the area of this rectangle 0 either by making length equal to 0, that is x plus 3 equal to 0 or x equal to minus 3, or by breadth equal to 0, which is x plus 2 equal to 0, where x will be equal to minus 2. So minus 3 and minus 2 are the roots of this quadratic equation. So visualizing this is, again, it's going to be very easy. If you relate with this diagram, now see this rectangle with length x plus 3 and breadth x plus 2. So when will it become 0? Here, x plus 3 is the length and x plus 2 is the breadth. You can either make the length 0 so that the rectangle area will become 0, or the breadth 0 so that again it will become 0. That is when x equal to minus 3 or x equal to minus 2. So the roots are x equal to minus 3 and minus 2. Now how can you visualize even this process? It's interesting. So from this rectangle of length x plus 3 and breadth x plus 2, now I can make length 0, assume that y-axis is here. So if I start pushing this to the left, this will start becoming negative. So when x is at minus 3, when x is minus 3, these two areas, that is what is there in red and what is there in green, will get cancelled out and the rectangle will disappear. Same way, if you want to make breadth 0, that is when I push this complete rectangle down, if I push this rectangle down, so it will start going below the x-axis. So here this will start becoming negative. When it's at -2, these two areas will get cancelled out and the rectangle will disappear again. That is why when x equal to -3 and x equal to -2, either when x equal to -3 or when x equal to -2, the rectangle is disappearing here because either length is becoming 0 or breadth is becoming 0. That is, from being 2-dimensional, you are making it 1-dimensional. It's actually becoming a line. So there is no area. So you can relate the two, what is happening here in numbers and what is happening in the diagram. Once you connect, it's becoming so simple. That's why you understand this completely now. So you know how to factorize a quadratic polynomial using numbers, and now you know how to visualize, not just how to factorize, and that's resulting in or that's helping you to find the roots. So I'm sure by this you have a much better understanding of factorizing quadratic polynomials. In this short section, I'll help you understand the behavior of the graph as and when you change the coefficients of a quadratic equation. Now we know that quadratic equation standard format is ax squared plus bx plus c. The quadratic coefficient is a, linear coefficient is b, and the constant part is c. If you visualize this, you will get something very interesting. So let's understand what happens when we vary the value of a, which is the quadratic coefficient. You know that when a is positive, graph will look like this, and when a is negative, graph will look like this. So starting from with a positive, we'll go all the way to a negative, and we'll understand what happens. So if I take y equal to 100x square, where a is 100, where there is no b and c in this case, y equal to 100x square, the graph, the parabola will be like this. It will be very close. When it's 10x square, it will open up and become like this. When it's x square, 1x square, it will become like this. If you open it up further, that is if you reduce a further, so you are reducing a here. When 0x square, it will become flat. That is y equal to 0 is x-axis. Now minus x square, it will start closing on the other side. It will be minus x square, minus 10x square, and minus 100x square. So you can see the clear pattern here. We just reduced a from 100 to minus 100. So from initially it was narrow, it got opened up, it became flat, and it started closing, and it became very close here. When by the time a became minus 100, that is where y was minus 100x square. So you can easily understand this pattern, what is happening from what I just showed you. So in this case, as you can see, starting from 100x square, 10x square, x square, then y equal to 0, minus x square, minus 10x square, minus 100x square. All of them are passing through the origin, right? The vertex is, they are all passing through the origin, because if you equate it with 0, you will get the root as 0 here, right? Because there is no constant part, that is why 0 will be a root. Now, what will happen if, so let's consider y equal to x square. So that this is the graph, y equal to x square. Now, if I want to move this parabola or this diagram, if I want to move this horizontally like this or like this, so horizontal shift, if you want to do it, how you are supposed to change the variable, let me make you understand. And this is not required for your exams, it's more from an interest point of view. So to move this to the right, if you want to move the complete parabola to the right, if I want to move 1 unit to the right, I just need to change y equal to x square to y equal to x minus 1 whole square. When it's x minus 1 whole square, it will move 1 unit to the right, like this. Now if I take x minus 2 whole square, it will move 1 more to the right. So where it will touch at point 2 here, at this point. If I want to move 1 more to the right, I need to write y equal to x minus 3 whole square. That will, and x minus 3 whole square, graph will pass through 3 or touch at 3 at this point. Where now if I want to move the graph on this side, I can write y equal to x plus 1 whole square, it will move 1 unit to the left, and x plus 2 whole square, it will move 1 more unit in this direction. X plus 3 whole square, it will be here. So this is how you can make the parabola do a horizontal shift. So now if you see how we are getting that, by initially y equal to x square will pass through the origin. Now x minus 1 whole square, it will shift 1 to the right. X minus 2 whole square, 1 more. And x plus 1 whole square, it will shift 1 to the left. My plus 2 whole square, 1 more to the left. It's very easy. So that's horizontal shift, right? Now if you want to shift the diagram vertically, vertical shift is done by changing the constant part. The last one is based on, if you see, the horizontal shift is done by expressing what we are doing is we are expressing the equation by using the completing the square format. Because when I write x minus 1 whole square, that's actually completing the square format, which all of you know how to express like that. So you can easily understand where if it's x minus 1, it'll touch at 1. The vertex will be at 1, the point in that parabola. Now, if you want a vertical shift, that's easy. So let's go back to y equal to x square. If I want to shift this vertically, the whole parabola vertically by 1, I need to add a constant 1 over there. So this will be x square plus 1. If I want one more, if I want to shift vertical shift by one more upside, I need to push this by 1. That means I need to make this x square plus 2, where the vertex will be at this point, which is 2 from the origin in the vertical direction. So that's x square plus 2. X square plus 3 will be 1 more up. X square minus will be from origin, I need to push 1 down. X square minus 1 will look like this. And x square minus 2 will look like this. So vertical shift is done by changing the constant part. Horizontal shift is by representing it in, it's actually changing basically the coefficient of x and expressing it in completing the square method. So horizontal shift is done like that. Vertical shift is just by, so x square plus 10 means it will pass through a point 10, it will pass like this. Minus x square minus 10, it will pass like this. So I'm sure now you know how the diagrams are changing as and when you change the coefficients of the quadratic equation. It is not required from an exam point of view, but once you know this, you know everything about quadratic functions to a level where you are talking about what will be the change in the diagram when you change the coefficient or the other way around.